This video is going to show you how to create the piston as part of the motion machine assembly. Now there's a lot of different ways to approach the creation of this piston, something like this. Um, there's kind of two parts of the piston. There's this round part up top, and then there is quite a few extrude cuts taken out of this section here. We kind of have the sides, which you can see from this view, are missing. Then kind of this whole inside part needs to be taken away. Then you have these grooves up near the top, and this pinhole which goes through the whole side. You can see here plenty of dimensions, should be enough dimensions and information to make this fully constrained. And then lastly, there's a 0.05 fillet on all the edges. So essentially everywhere you can, you put the fillet except on the piston ring grooves. This section here is really important. It shows you the depth that we're going to cut this design to. This is essentially a section view, or if we took this view and cut it halfway where you see the B, that's what we see. So that's very good information. And here's your isometric kind of 3D view. And this is symmetrical. It's essentially mirrored on the other side. So a lot of different ways to make this. Nothing right or wrong as long as you get the correct dimension, size, etc. So I'm going to go ahead and start this. I think I'm going to do it in kind of a simple approach. I'm just going to create a slug, 2.5 inches in diameter. And what is my height here? Total height is 2 inches. So I'm going to approach it that way. Got my slug here. As you can see, I got a lot of work to do to this. It's almost like I'm taking a billet of aluminum and CNC machining to get this. It's not the way they're actually made. Usually they are cast or forged, but kind of a good little way to get some skills here. I'm going to start on the bottom and start working on this pocket here. I'm just going to rough sketch this out. Let me zoom in on this guy right here. A lot of information here that I need to be aware of. Oop, too far. Okay, so a lot of information. I got dimensions on the end point of this large arc, a distance between here, or wall thickness, I guess you would say. There's some references to center lines. Just draw it and put it in dimensions. That's how I always do it. So let's see, I'm going to start here. If I'm careful, I can do most of this with my line tool. There is a small line between these arcs here. Then there's a big arc here. And then another arc. Line. Another arc. Another line. Now, obviously, this is not going to be dimensionally accurate yet, and that's okay. Absolutely okay. Plenty of time to do all that. Okay, so kind of have the rough shape here. Now you'll notice that these arcs, these large arcs, are concentric with the piston, so that's an easy one to start with. Okay. I need to bring, obviously, this guy up. Okay, let's see. I'm going to put in some construction lines left to right from the origin. There's going to be a lot of dimensioning. I'm going to use a lot of symmetry on this too. It's not a constraint that I use a lot, but it's going to work perfect for these purposes. Okay. And actually, one thing that might help suck this all up is to put in this dimension here, this 96 degrees. This is actually referring to this arc. So end point, center point, end point. It's a lot more than 96. It should kind of bring everything back up, kind of. Use the symmetry on it now. So symmetry, I'm going to do the same thing. So if I can find it. So symmetry from end point. Where'd you go, end point? End point, end point, center point. And it makes it symmetrical. It's actually a pretty useful one. I'm going to do the same thing with these vertical lines. Yes, it is super goofy right now, but that's okay. I can kind of drag things back to where they need to be. Oop, oop. Sometimes. Sometimes it just gets too goofy, but we'll see what happens here. All right. I'm going to put a point on this guy right here on the center line. That really lets me do my wall thickness here. So the 0.18 or 3/16 of an inch. Now that's set. Let's see if I start shrinking down these arcs. Hopefully it'll bring things back in line. I can see here that all the arcs on this, all these small turns are all 0.125. Okay, got that back. This guy's also going to be 0.125. And then obviously these are all nice and smooth, so tangents are the name of the game. Oh, it's already got a tangent. We're going to need a tangent down here though. All right, that looks much better. Let's try the same thing over here. Tangents there, we need one here. And let's see if my equals is going to do what I want to do. Good, good. All right, that part looks good. Let's start on this side now. Let's bring these guys back to earth. A lot of equals. I think I'm just going to keep using equals for these 0.125s. Okay, getting there, kind of coming back to what it's supposed to look like. Sometimes it can get a little crazy on you, but just take it step by step. It usually will work out. I did the same thing here, put that point, and I could probably use an equals. So let's try that. Those two guys are equal. And I know that because everything here is symmetrical. That's just a good assumption, especially with engine parts. That's how they maintain balance. Although, I don't want to get into the weeds, but some pistons are purposefully, the hole is not drilled perfectly in the middle, but that's way, that's not something we'll deal with normally. All right, so I have a few more dimensions here. So I have a 1 inch between these two verticals. I'm going to put that in here. Once my computer catches up. 1 inch. And I'm also going to put a symmetrical here as well. So line, line, center line. And actually that looks perfect. There's also these two cuts on the side. Don't forget about those. And those are not construction lines. Okay. Now, knowing the wall thickness, I'm going to assume that the wall thickness between these guys is also 0.188, especially if I don't see any other dimensions. That's a good assumption, but I bet there are some dimensions for that. So let's see here. So I have a distance between these two sides, so let's use that instead, 2.06. And because they are vertical, that should be all that I need. I'm just going to make them equal to each other, and then they should have nowhere else to go. Perfect. So now I'm going to cut that into my design. And the height of that cut is 1.562. Make sure the operation is a cut. And I always like to go fly over and make sure it's going to do it at once. So here the problem is no target body found. Well, it's because it's going the wrong direction. So go to the other side, in which in Fusion you just put a negative in there. Now we're cutting what we're supposed to cut. Minus 1.562. Okay. All right, so there is the major cut on the piston. As you can see, we have lots of sharp corners, so the last step is actually going to be doing a fillet on everything. In the next video, I will show you how to do the wrist pin hole, the grooves, and put that final fillet on everything. So this is video 1 for creating the piston for the motion machine.